Now, before you start the part of the experiment where you're heating the syringe up and then cooling it down and studying the gas properties, you should prepare some ice water, and you should get some calcium chloride solid from the cart, a couple 100 milliliters in a beaker, and you should prepare a saturated calcium chloride solution, and you should let that cool down in a bath of water so it's close to room temperature. Okay. Now, the experimental setup should be arranged the way that you can see here in this shot. One thing to take note of especially is the siphon here. Now, a siphon is a tube that's been pre-filled with water, shouldn't have any air bubbles in it, and you want to arrange this clamp here so that the hose is kept safely away from the hot plate. Later on, when we turn on the hot plate, we don't want this hose to get melted. This is a procedure for preparing the siphon for the water bath. So the siphon is just a tube. One end is going to have a pinch clamp on it, and it has to be pre-filled with water so that there are no air bubbles in there. Right, so the best way to do this is to get the water going at a sort of moderate rate. You don't want it squirting all over you. And open up the pinch clamp and force the water through the tube. You see it coming out on the other end. And you want to make sure there are no air bubbles. And then when there are no more air bubbles popping up at this end of the tube, you can close the pinch clamp. Right? If there's any air that's still on the top and the bottom, you can fill it. Right? You want to get them almost filled to the top. It can tolerate a tiny little bit of a bubble, but ideally we'd have no air bubbles at all. All right, you can stop. Other things to take care about or check are to make sure that the hose is not draining. If the pinch clamp isn't squeezing hard enough, you'll see liquid draining here, possibly slowly, but it'll be draining. And that means the bath will be getting drained. You don't want that to be happening when you don't want it to happen. If that happens, you could take the pinch clamp, and you can try just clamping and unclamping and see if it gets it tighter. Or you could slide the hose up closer to the loop part of the pinch clamp. That'll squeeze it more tightly. Okay. The other things to take note of are the position of the thermometer and the syringe. Notice the syringe, if you look from the top, is almost all the way over at one side of the beaker, right? And that's because later on, when we have ice and calcium chloride solution in there, it's going to be cloudy and your view is going to be possibly blocked by ice cubes. And you want to make sure that you can clearly read the markings on the syringe. So position the syringe, turn it so that it's facing outward, and put it close to one wall of the beaker like I've shown you there. To take note of is the overall position of the equipment. Notice that the hot plate has to be turned on its side in order to be able to get this three-prong clamp to reach all the way over onto the other side of the beaker. And notice, in order to get really close in the back here, you have to turn the ring stand around and point it, kind of opposite of the direction we normally do. All right, so to put the siphon onto the apparatus, you want to cover the open end with your finger and put it underneath the liquid level of the bath, like that. And you can catch it with this clamp to hold it in place. Okay? You'd like the siphon to go to about the bottom of the bath, and then take the pinch clamp and you can put that end into the small sink on the desktop. That's good. Now, to start the experiment, you want to turn the heat on, and in the beginning you can turn the heat up all the way, right? We want to warm the water bath from room temperature. It's probably somewhere in the 20s now, up to around 35 or at most 40 degrees before we turn it down. After we turn it down, it's going to still rise a little bit in temperature, and our goal ideally would be to get a temperature of around 45 degrees as the maximum that we see. As you heat the bath, it's a good idea to stir it so that you have a uniform temperature throughout. You want to make sure the bottom isn't a lot hotter than the top. Okay? So we're going to be heating for a couple of minutes now, and we can give it a stir every minute or so as we keep our eye on that thermometer. Now, as the water gets heated up, the gas inside the syringe also does. And Charles's law tells us that gas is therefore going to have to expand. So if you watch closely during the heating, you probably will see bubbles come out of the tip of the syringe. Right? That actually is another example of Charles's law, though it really isn't the example that we're studying today. Right? In today's experiment, our data collection is really going to start when we reach the maximum temperature, and then we turn around and we cool the solution down. But if you watch closely, you will see bubbles forming on the tip and then eventually come out. Right? That's normal and to be expected. Now, if you look closely, you can see a bubble starting to form on the tip of the syringe, like I was saying. Now, the temperature of my bath has reached about 35 degrees, so at this point, I'm going to completely turn off the hot plate. And I'm just going to continue to occasionally stir the bath and monitor that temperature. Now, our ideal temperature, our goal temperature, is about 45 degrees, but what's important here is that you write down the maximum that you see. So your data can be perfectly acceptable if it goes up higher than 45. If it goes to 50, you can write that down and use it. Your calculations can be very, very good. But whatever the maximum temperature is, the temperature we're going to record. That's really when the experiment's going to start. Now, my temperature got up to about 46.2 degrees, and then it started to turn around. So I'd write down 46.2 as the temperature for my first trial. And if you have a bubble that's on the tip that looks like it's going to come flying off, it would be a good idea at this stage to shake it off like that. We don't want it to get sucked back in as the gas inside the syringe cools. We want, as it cools, we only want it to suck back in liquid water. Okay. So the maximum temperature that I saw on my thermometer was 46.2 degrees, and that's what I write down for trial number 1. Now, for the first trial, all you have to do is record that maximum temperature that you got. And for the other trials, we're going to lower the temperature, and you're going to see that gas gets replaced by liquid. Liquid gets sucked into the tip of the syringe here, and we're also going to have to read the volume of liquid that's there. So what we have to do now is to lower the temperature of this bath about 20 degrees. Our goals for the trials are to have first one be about 45 degrees, the second one about 25, the third one about 5 degrees. And there's a trick I'll show you. We can even try to get the bath down to minus 15 as our fourth trial. So what we want to do to lower the temperature here is drain out a little bit more than half of the water. Right? There's about 1,000 milliliters in here. We go down to about the 500 milliliter mark. And the way we do that is you take the pinch clamp here, and if I open up the pinch clamp, you'll see if it's been pre-filled with water, it will siphon out the water. Right. Okay. All right, so that's around the 500 milliliter mark. And I'm going to replace the water that I just drained out with ice water. And in this trial, I'm going to try not to get any ice added to the bath. I'd like to just add the ice water itself. And I'm going to add up to about the 1,000 milliliter mark again. Stop. Now I've been stirring for a few minutes after adding the ice water, and I can see that my thermometer has stopped changing quickly. Right? So there's 2 pieces of data I want to collect at this point. I want to look closely at the thermometer here and read that. You should read that to 1 decimal place. And you should also see that some liquid has been sucked into your syringe. Some of the water bath has been sucked into your syringe. And you should look closely at that and make a measurement of that volume. The gas that's in there is the same number of moles, but it's occupying a smaller volume because it's at a lower temperature. Okay. Now that we've collected data somewhere around 25 degrees, or well, anywhere in the 20s would probably be okay. We want to lower the temperature now close to 5 degrees. And to do that, we're going to do something similar. We want to drain out water from this bath. In this case, though, we'd like to drain out as much water as we possibly can. You see it draining there. We'd like to drain out as much water as we possibly can while not going below the tip of the syringe here. Right? We want to make sure the tip of the syringe is always underneath the liquid level. But we'd like to get out as much water as we can and replace it with ice to get the temperature as close to 5 degrees as possible. Okay, I'm going to stop there to be safe. Right? And just for your reference, if you have your apparatus set up like mine, I'm at about 450 milliliters of water in there right now. And that water I'm going to replace not with ice water, but just with pure ice. And again, I want to go up to about the 1,000 milliliter mark. Right. Okay, now I've been stirring for a couple of minutes, and my thermometer, my temperature has dropped a lot. I've got a temperature on there of about 3 degrees, actually. So anywhere in the neighborhood 5 would be fine. Anywhere from probably 0 to 10 would be good. So it's not changing very much now with a lot of stirring. So I'm going to write down that temperature. And again, I'm going to look closely at this syringe. And if you look closely, you should see even more liquid has been sucked in. And you want to read the volume of liquid that's been sucked in there and record that in the data table. Stop. Now, for the last trial to get down to minus 15 degrees, we're going to have to drain out, again, as much liquid here as we can without getting the syringe exposed to the outside air and having a chance for other gas to get in there. And instead of replacing it just with ice, we're going to replace it with a mixture of calcium chloride solution and ice. And we're going to take advantage of an effect known as the freezing point depression effect. So the first thing I want to do is I want to drain out as much liquid as I possibly can without exposing the tip of the syringe, just like I have before. You can see my siphon is draining out there. And I'm going to keep my eye on the liquid level here and make sure that I don't get below the level of the tip of the syringe. Okay, I'm going to stop there to be safe. Okay. Now, what I'm going to do in place of that liquid that I've drained out is I'm going to add some of this saturated calcium chloride solution that I prepared earlier. Right, I'm going to first add that up to about 1,000 milliliters. And when I put that solution in and I start stirring, what we see with the freezing point depression effect is a lot of the ice is going to melt, but the temperature of the whole mixture will drop. So in order to get to the lowest temperature, we have to have a mixture here that is mostly ice, very little liquid portion, and we have to get there through several stages of adding ice and adding calcium chloride or adding calcium chloride solution and doing a lot of stirring. All right, so as I start to stir here, I will see the temperature drop and you'll see it going below 0 very quickly. But as a lot of the ice melts, we're going to have to refresh it with more ice. Right? So I see the temperature drop now. I am a little bit below 0. So I have to drain out as much as I can. There's my siphon draining. Again, without exposing the tip of the syringe. Now in the first addition, we're going to add saturated calcium chloride solution. And in the later additions, we're going to add ice and solid calcium chloride. All right, I'm going to stop there to be safe that I don't get the tip exposed. All right, now I'm going to replace that liquid again with ice this time. Okay. And I'm also going to throw in some solid calcium chloride. All right, the exact amount is really not that critical. I had about 200 milliliters in here. And I'm going to work on pressing it down and getting it mixed into this mixture. It's kind of a rough job. All right. Stop. Okay. Right now, I was stirring for several minutes, and a lot of the ice melted. So I put more ice in, and I added a little bit more calcium chloride. And the lowest temperature I've been able to get here is about minus 6 degrees. So that would probably be okay if you can get down to minus 15. I did in other attempts, was able to get that cold. But I think a temperature of around minus 5, I think at least would be an acceptable temperature for this trial. And again, as you're stirring, one thing you want to be careful about is to make sure you don't bang the syringe, right? We don't want the volume inside there to change. Right? So for this last trial, just as with the other trials, we have to record the volume that's there and whatever temperature we get down to here.